number patterns. We're going to look in this lesson at linear patterns and graphing linear patterns. So the linear pattern 7, 12, 17, 22. Now this pattern will go on indefinitely. So what can we say about this pattern? We can say that the difference between all of these numbers is 5. And this is how we identify if a pattern is linear. The first difference between the numbers is the same. Now I'm going to use the formula that you can use for coming up with Tn. Tn is the general term of a linear sequence. Put these notes into your copies. The general term of a linear sequence. You may be asked to find Tn, and if you don't know what it means, you won't be able to do it. So Tn is the general term of a linear sequence. Now I'm going to do it a different way than the formula first. If we have the difference, if we just write the letter n beside it, and then we look at the first number, all we need to do is we need to decide, do I need to jump, do I need to add, or subtract a number to get from this number 5 to the number 7. So I'll rewrite it here. 5n is the difference times n. How do we get to the number 7? We have to add 2. So this is the quick way to find Tn of a linear sequence. There is a formula as well that we can use that's in the formula booklet. It's Tn is equal to a plus n minus 1 times d. And this is exactly the way it's written, where a is my first term, n stays as n, and d is the common difference. So let's see how, by putting our information into this formula, and you can choose which one to use. I prefer the quick method, but we're going to do it both ways within this lesson. So my first term, we're trying to calculate Tn. My first term is 7. This 7 here. Plus n minus 1. N is always in Tn times the difference, which is 5. So now we have to use a little bit of algebra. 7 plus 5 times n minus 1 is 5 times n, and 5 times minus 1. And you can see that 7 minus 5 is 2, so we end up with 5n plus 2 is Tn, which is exactly the same as what we had up here. Now some students prefer the formula, some students prefer to learn a method that they can use all the time. So let's look at another question. The sequence 3, 7, 11, 15. You're asked to find Tn. So doing it the quick way, the difference is 4. We write n beside 4, and we say, how do I get from 4 to 3? I have to take away 1. So Tn in this sequence is 4n minus 1. Nice easy method. If we're to use the formula, Tn is equal to a plus n minus 1 times the difference. A is my first term, so we're going to have a 3 plus n minus 1 times my difference of 4. So we get 3 plus 4 times n minus 1 is 4n minus 4. So you're going to end up 4n, and 3 minus 4 is minus 1. So you can see you're still going to get the same answer. So let's do one where we have to find, say, the 50th term of a sequence. So find T50, this is the way it will be written, find T50 of the sequence, or of the linear pattern. It can be called either. I'll call it linear pattern in this case. And we're starting with the number 2, and we're jumping to the number 10, and then we're going to the number 18, and then we're going to the number 26. So find T50. Let me just make that a little bit clearer. T50. So what am I jumping each time? I'm jumping 8. I multiply it by n. How do I get from 8 to 2? I have to take away 6. Tn is equal to 8n minus 6. If you want to use the formula, Tn is equal to a plus n minus 1 times the difference. A is 2, the difference is 8. So 2 plus n minus 1 times 8 is 2 plus 8 times n, and 8 times minus 1. So you're going to get 8n minus 6. So either method is absolutely fine. You choose which one to use. Now T50, what has n become? N has become 50. So we're going to say 8 times 50, n is 50, minus 6 is 400, minus 6, which is 394. So getting the Tn enables us to get a number rather than having to write out 50 numbers to get to the term 50. We're able to use the formula to find T50. What about T100 over this side? What would term 100 be? 8 times 100 minus 6, which is equal to 800 minus 6, which is 794. Now I have 2 to test yourselves with. Find T100 of the following 2 linear sequences. Pause the video, try the questions, and see can you get the answer. Okay, so I've deliberately put in a minus number. This is what happens in exams. Are you confused? Well, you shouldn't be. What's the difference? You can see the difference here is 10. We multiply it by n, and we decide how do I get from 10 to the first number, which is minus 3. I have to take away 13. So that's my Tn. So T100, 100 replaces n. It's going to be 110 times 100 minus 13, which is 1000, minus 13, which is equal to 987. For this one here, now you may have the mistake that people will make is they'll write the difference as 6, but in fact the difference is minus 6. So how do I go from minus 6 to 12? I'm jumping now. I'm going from minus 6 to 12. So I've got my n beside my difference. I'm going from minus 6 to 12, which is plus 18, which is equal to Tn. So T100 is equal to minus 6 times 100. Careful with the difference is a minus, plus 18, which is minus 600, plus 18, which is minus 582. So if you didn't get these two correct, try them again and maybe set up some sequences yourself and test yourself to see can you create a sequence and find T100. Okay, so let's have a look at the graphing aspect of linear patterns. They can make these questions up in any way. It could be a plant growing, it could be someone saving, anything that has linear growth. So we're told here that Jack has €2 and saves €3 a day for 5 days. So he starts with €3. Now, anytime we're told about something starting, we call that day 0, and we're going to see this on an X and Y axis now in a minute. So Jack has €2 and saves 3 a day for 5 days. So he has 5 on day 1, he has 8 after day 2, 11, 14, 17. What about Jill? Jill starts with €4 and saves 2 a day for 5 days. 6, 8, 10, 12, 14. So you're told to fill in the chart, which we've done. Now you're asked to graph both sequences. So I'll just leave the numbers so you can see them. So we're asked to graph both sequences. So this is an X and Y axis. I'm just going to do the positive aspect of it. Now we know that that's 0 on the X and Y axis, so that's our starting point. We have day 1, 2, 3, 4, and 5. And now we go to our answers and we say, well, what's the highest number? I need to go up to 17. So I might just bring it up a little bit more and we'll go up in 2s. So I'll go 2, 4, 6, 8, 10, 12, 14, 16, 18. And I don't have to put all my numbers in. I can go 2, 4, 6, 8, 10, 12, 14. Let me just make that closer. And my 18, instead of squashing loads of numbers in. And then down here, 1, 2, 3, 4, 5. Now, what are these? These are days. So always label your diagram. And in most exams, you'll be given the chart. You don't have to do this yourself, but I would highly recommend practicing drawing these. And on the left-hand side here, we have euros. We could write euros, or we could write the symbol euro. So I'll stick with red, and we'll look at doing Jack's graph. So on day 0, he had €2. So this is day 0, €2. After day 1, he had €5. So approximately here. On day 2, he had €8. On day 3, he had €11. On day 4, he had €14. And you can see these are making a straight line. On day 5, he had €17. And we're going to connect these dots. Now, obviously, you're going to use a ruler. I don't have a ruler on this app, so you'll be more accurate in your workings here. Okay, let's look at Jill's in green. On day 0, she had €4. On day 1, she had €6. So still a little bit more than him. On day 1, she had €6. On day 2, they had an equal amount, €8. On day 3, she had €11. Sorry, on day 3, she had €10. On day 4, she had €12. And on day 5, she had €14. So approximately, I say approximately because, as I said, I don't have a ruler, but approximately like that. So use the graph. We've graphed both sequences. Use the graph to find out when they have the same amount. Well, we can see here in our chart. So anytime you have the information, you can see here €2. Day 2, €8. If we go to the left, that's my €8. So day 2. And now we're asked to use algebra to confirm our answer to part 2. So this is where it gets a little bit more accurate. So what we need to do is we need to get Tn of each sequence. Now it's really important here when we're getting Tn that we don't count day 0. We just start with day 1. So Tn for Jack, I'm going to be looking at 5, 8, 11, 14. So 5, 8, 11. So my difference is 3 multiplied by n, and I got to add 2 to get to 5. So that's Tn for Jack. Tn for Jill. And her sequence is 4, 6, 8, 10. I don't need all the numbers, but the difference is 2. And I got to go from 2 up to 4. So I add 2. And algebra is when are these two things equal? I'm going to write 2n plus 4. I started, let me just rub this out. I started with day 0. I should have started with the 6. So listen to your own information. 6, 8, 10. So 2n plus 4. So always check back over your work and you'll see mistakes if they occur. So just solving this for n, we bring the 2n to the left, 3n minus 2n, and I bring the 2 to the right, 4 minus 2, and I get 1n equals 2, which is what we had up here, day 2.